Welcome to this video where we're going to look at 5 random GCSE questions from a paper 1 non-calculator paper. These are grade 7 to 9 questions. This is the first one, and we've got to rearrange this formula and make x the subject. So this is what we do. We start by multiplying both sides by the denominator. So we have y multiplied by 2x squared plus 1, and that is equal to x squared minus 3. Okay, now I multiply out the bracket to give me y times 2x squared, so I'll write that as 2x squared y plus y, okay, equals x squared minus 3. The next thing is to get all of the x terms on one side, all right, and all of the non-x terms on the other. So I'm going to start by writing 2x squared y minus x squared, removing it from the right, and that's going to be equal to negative 3 minus y. Okay, the next thing is to factorize out the common factor of x squared. So I'm now going to a situation where the x squared term only appears once. Okay, and it's 2y minus 1. And over this side I've got minus 3 minus y. I'm now going to use a useful little trick to get rid of all these minus signs. If I multiply both sides by negative 1, this becomes x squared, and the negative of 2y minus 1 is 1 minus 2y. Okay, and the negative of minus 3 minus y is plus 3 plus y, so it's just 3 plus y. And that tidies it up a lot and removes some of those unwanted minus signs. Now we just divide both sides by this bracket to give us x squared equals 3 plus y over 1 minus 2y. Okay, and finally we just need to square root both sides. Okay, so the last step is to say that therefore x equals, okay, now because we're square rooting it, we have plus or minus the square root of this, so I'll just take a copy of that, okay, there, and put that there, and around it we're having a square root sign. Okay, so it's like that, and a little tick at the end of it there like that. Okay, and that is the answer to the first of these 5 quick questions. Next question. This is about ratio, and this is a hot topic in GCSE these days, so let's make sure that we can do this one properly. So using this first line of information, we know that A must be 5/4 of B just by dividing both sides by 4. Okay, so I'm just going to make a note of this here, that A is equal to 5/4 of B. Okay, now I'm just going to work on this and we'll see a strategy forming in a moment. And I know that C is 3/4 of B. Okay, and of course B is 4/4 of B. So I'm just going to write B as being 4/4 of B. Okay, I know it sounds very obvious, but that will help us fit that in with the others, as you'll see in a moment. And C, from this information, is 3/4 of B. Okay, now the next one we've got to work out is what D is. If we can do that in terms of B as well, then it's going to be very straightforward to sort it out. So we know the ratio A to D is 3:5. So we know that A is 5/4 of B, Okay, so I'm just going to do that bit over here. I'll do that down here. So A to D could be written as this, you see. A to D, which we know is 3 to 5, because it tells us that in the information. And we also know that A is 5/4 of B. So I'm going to write 5/4 of B on this side, okay? And to get D on the other side, I need to put them in the ratio 3 to 5. So I need to multiply this thing I've just written down by 5/3. Okay, so 5/3 of 5/4 of B. Now you'll need to do working out to show how you're getting this answer, because it's not something you want to be trying to do in your head. So let's just simplify that last part. That's 25 over 12b. 25 over 12b. Okay, so I'm going to write D as 25 over 12b. So now all 4 of the letters are in terms of B, which means the B's cancel. The only thing I'm going to need to do is put all these into 12ths as well. Well, that's easy to do. I just have to multiply each one by 3. Okay, so that's going to be 15/12ths of B. Okay, this one is going to be 12/12ths of B. And this one here is going to be 9/12ths of B. Okay, and the fourth one I've already written in terms of 12ths of B, which is 25. So now I can make the comparison between these 4. They're all in 12ths. So the B's cancel, the 12ths cancel, and I'm left with the answer, which is 15 to 12 to 9, okay, and 25 at the end. Okay, so a bit of careful working out needed there, and you just need to have a system, a methodical system, and just take great care. Okay, and that's the answer. Next question. This one is about circle theorems, and it's got a circle with a center O. It's giving you some information about angles, and it's telling you that the angle ABO to the size of angle ODA is 2 to 1. So if this is Y, it means this here must be 2Y. Okay, so this angle here is 2Y. Write it into the diagram, because you're just using the information that you're given. Okay, find an expression for Y in terms of X. Now, it says you must show all your working. It doesn't ask you to give angle reasons, all right? So you don't need to actually write down any reasons, but you do need to show the working, and that can be done on the diagram, a lot of it. So we know that this is 3x, and we should know that this is 6x. And the reason for that is because it's the angle at the center is twice the angle on the circumference. Okay, now I'm going to use some other information about this shape. This here is a cyclic quadrilateral. Okay, so the opposite angles in a cyclic quadrilateral are equal to, add up to 180. So if this is 3x, this angle down here is 180 minus 3x. Okay, so that is my working. I'm not stating the reason here because I'm not asked for any reasons. Okay, so I've now got all 4 angles inside this quadrilateral ABOD. Okay, and I know that the angles in a quadrilateral add up to 360. And I've got to write y in terms of x. So I'm just going to make a statement here. This is my working, you see. I've got 2y plus y plus 6x plus 180 minus 3x, and all of that added together I know is going to be 360. Okay, so I've just got to rearrange this and get y equal to a function of x. Well, I've obviously got 3y there at the front. I've got 6x minus 3x, which is just plus 3x, and I've got 180 and I've got 360 on this side. So if I take 180 from both sides, it's going to leave me with 180 on the right. Now, everything there has a common factor of 3, so I can quite easily divide everything by 3 to give me y plus x equals 60. And therefore, y must be 60 minus x. And that's the answer. Okay. The fourth question. This is about using the rules of indices and powers and surds and linking the two together. You've got to be very careful with this and do it step by step. The first thing I would do here when you see a negative power is rewrite that as 1 over 12 to the same power but positive. So it's now to the power of 3 over 2. Okay, so that's 12 cubed square rooted. That's what that actually means. And the next step, I'm going to do it like that. I'm going to take the root of 12. So I'm going to write it as 1 over the square root of 12 cubed. Okay, like that. Because the half means the square root. Now, I'm going to use some knowledge about surds, and I'm going to say the root of 12 is the root of 4 times the root of 3, okay, which is 2 root 3. So it's 1 over, now it's 2 root 3, all cubed, okay, so you've got to cube both terms in that bracket. Okay, the next step is to, well, cube each part, so it's 1 over 8 times the cubed root of 3, sorry, the square root of 3 cubed is root 3 times root 3 times root 3, which is 3 root 3. Okay. The next step is to put the 8 and the 3 together to make 24. Okay, so it's 1 over 24 root 3. Okay, but it's not in the form I need. I need a root 3 on the numerator. So all I'm going to do is multiply the numerator and denominator by root 3 to get root 3 over 24 root 3 root 3. Okay. Lots of steps. I'm deliberately doing that because I want you to see that it needs to be properly constructed. Okay, and of course root 3 times root 3 is 3, so that's actually the same as root 3 over 3 times 24, which is root 3 over 72, which is the correct answer. H is the number 72. Okay, but you need to put all of those steps in. There are other ways you could do it similar, but it would still involve quite a few steps. Okay, and finally we have this question about completing the square and understanding how to use it. So there's two ways you can do this. The best approach is to take out in this case, a factor of 3 just from the first two terms. So I'm going to write this initially as 3 lots of x squared minus 8x. Okay, but I'm going to leave the plus 38 out of it. Okay, so I'm just taking the factor of 3 out of the first two terms only. Now I'm going to complete the square for this bracket. So I've got 3 lots of, and it's going to be x minus 4 all squared. Okay, and that's going to leave me with a plus 16 at the end. You see, if you did that, if you did x minus 4 all squared, I'll do it over here, you're doing x minus 4 times x minus 4, and it will give you the 8x, it will give you the x squared, it will give you the minus 8x, but it will also give you a plus 16. Okay, when you do the negative 4 times negative 4. Now I don't want the 16, so I need to take that away. Okay, close that square bracket. So that square bracket there is equivalent to that one there, but I've also got this 38 tagged on the end as well. I don't want to lose that. Okay, now I can multiply out the square bracket. So I have 3x minus 4 all squared minus 3 times 16, which is minus 48, plus the 38. Now I can combine those two terms at the end to give me the final answer, which is 3 lots of x minus 4 all squared minus 10. Okay, so that's now in completed square form, and hence or otherwise write down the coordinates of the turning point on the graph, the minimum point. So this happens when the lowest value this bracket can ever take is 0, because when you square something, the minimum value it can be is 0. Okay, so that happens when x is the number 4, all right, because 4 minus 4 is 0. So basically the minimum point is 4, comma, and it's negative 10, because when x is 0, the value of this is 0. When x is 4, the value of the bracket is 0. This whole thing here is 0, and you're left with minus 10. Okay, and that's the coordinate of the minimum point on that graph. And that is the end of those 5 questions. Any of those questions could appear on a calculator paper, okay, but none of them required a calculator, so they could and were indeed on a paper 1 non-calculator. Hope that was helpful. Take care.